Hello everyone. So today I'm going to talk about the Dijkstra's algorithm. So Dijkstra's algorithm is basically a graph algorithm that is used to find the shortest distance between a vertex and any other vertices in a given graph. So for example, we have a graph on the left with the distance between any two vertices labeled on the edge, and we want to find the shortest distance starting from say vertex 0 to any other vertex. So our final goal is to construct a shortest path tree as shown on the right, which indicates the shortest distance from vertex 0 to say vertex 2, vertex 3, and etc. So here are the main steps of the Dijkstra's algorithm. So the first step is to create a shortest path tree set that keeps track of vertices included in the shortest path tree. So if a vertex is included in the set, it means its distance from the starting vertex has been finalized, and it is truly the shortest distance. So initially, this set is empty. So the second step is to create a distance list. And initially, all the values in the distance list are infinite. And we assign the value of 0 to the source, to the value in the list corresponding to a source vertex, since the distance of every vertex to itself is 0. And thirdly, we have a loop. And firstly, we pick a vertex which is not in the shortest path tree set, and it also has the minimum distance value from the starting vertex. So we include the vertex called u into the set. And the next step is to update the distance value of all the vertices adjacent to u. So if the sum of the distance value of u from the source and the length of the edge uv is smaller than the distance value of v in a distance list, then we update the distance value of v. So here's an example of the Dijkstra's algorithm applied to a graph. So firstly, we initialize the shortest path tree set to empty, and we initialize the distance list of all the vertices to infinity except the starting vertex, which is the vertex 0, and we initialize it to distance 0. And in the first iteration, we choose a vertex that is not in the set, and it also has the minimum distance in the distance list. So we know that this vertex 0 has minimum distance to the starting vertex, and we include it in the shortest path tree set. And then we also update all adjacent vertices that is adjacent vertices to vertex 0. And those vertices are vertex 1 and vertex 7. And using the distance of the edges from the vertex 0, we can update these values in the distance list accordingly. So here are the next two iterations of the Dijkstra's algorithm. So since 0 is already in the shortest path tree set, we found that vertex 1 is not in the shortest path tree set, and it has the minimum distance in the distance list. So next we add 1 to the set and we update the adjacent vertices of vertex 1. And however, we found um, that 4 plus 11 is actually greater than 8. So we don't update the value at 7. However, we found that the value of 12 is smaller than infinity. So we update the value at vertex 2 to 12. And these are reflected in the distance list. And in the next iteration, we found that 7 is not in the set and it has smallest distance in the distance list, which is 8. And then we update the value of adjacent vertices of vertex 7, which are vertex 6 and 8. So if we perform the Dijkstra's algorithm in this way, finally we will construct the shortest path tree like this, and as shown on the bottom right. And the value at each vertex indicates the shortest distance from vertex 0 to that vertex. So here's a lead code question in which we can apply the Dijkstra's algorithm pretty easily to solve the problem. So in the question we have a graph which consists of n vertices, and we also have a set of directed edges from one vertex to another, and the length of the vertex indicates the time it takes for a signal to reach from the start vertex to the end vertex. And the problem asks us to find the time it takes starting from one vertex and for the signal to reach all the vertices in the graph. So if we apply the Dijkstra's algorithm from the starting vertex that is specified by the problem, we can find the shortest distance starting from this vertex to any other vertex pretty easily. And if we take the maximum of all the distances starting from the starting vertex to any other vertex, that is the answer for the time it takes for all the vertices to receive the signal starting from that vertex. So the lead code problem and my answer can be found on this URL, and thank you for listening.